Alright, so this is number 367. The coordinates of the triangle are this. Triangle R prime S prime T prime is the image after a 90-degree rotation about the origin. State the coordinates of the vertices of the triangle's image. The use of the set of axes below is optional. Okay, I'm not going to use the set of axes below because I know that a rotation of 90 degrees takes any xy coordinates and turns it into negative y comma x. So I'm just going to use that rule. So I have R, S, and T. R is at negative 2 comma 3. S is at 4 comma 4. T is at 2 comma negative 2. So what happens is we get R prime, S prime, and T prime. R prime would be negative 3 comma negative 2. S prime would be negative 4 comma 4. And T prime would be 2 comma 2. So that's it. Here is my answer. Okay? Let's see, the coordinates of a triangle are this. State the coordinates of the image after a rotation of 90 degrees about the origin. So this is the same deal. A rotation of 90 degrees takes xy and turns it into negative y x. So we have A, B, C. A is 1 comma 2, B is negative 4 comma 3, and C is negative 3 comma negative 5. So they will all change to the image. Okay, A prime would be negative 2 comma 1, B prime would be negative 3 comma negative 4, and C prime would be 5 comma negative 3. And since the graph is optional, I don't need to use it. Okay. Point A is located at 4 comma negative 7. The point is reflected in the x-axis, so a reflection in the x-axis takes x comma y and turns it into x comma negative y. So 4 comma negative 7 will go to 4 comma 7, which is choice 3. So a reflection in the y-axis takes x comma y and makes it negative x comma y. So 2 comma negative 3 would become negative 2 comma negative 3. Choice 2. Let's see. Okay, a reflection in the line y equals x. What is that one? I forget. Hang on a second. Let's see here. It's got to be in my note card somewhere. See, I'm allowed to forget these things too. Okay. It switches around the coordinates. So xy goes to yx. Okay? Well, what was the one I was confusing it with? One of them. Oh, a rotation of 180 is the one that I was confusing it with in my head. Because a rotation of 180 is negative x comma negative y. Just want to find that one. Yes, okay. So, if I have negative 3a, comma 4b, that will become 4b, comma, negative 3a. Choice 1. State the coordinates of the image after it's reflected in the line x equals 2. So that would be this line. So I would have y prime z prime and x prime. So x prime would be 3, 1, y prime 2, 4, and z prime 5, 4. Okay. So let me just double check that. 1, 2, 1, 2, 1, 2, 3. So that's 5, and 1, 2, 3, 1, 2. Okay. So that's it. 373. After the reflection in the x-axis, the use of the grid is optional. Remember, reflection in the x-axis takes xy and turns it into x negative y. So we have A, B, and C, and it goes to A prime, B prime, and C prime. Negative 2, negative 2, negative 1, 3, 4, 0. Okay. Under this same, so the transformation, so A went from 1, 3 to 4, 4. So A prime. So I went from 1 to 4, that was plus 3, and from 3 to 4, plus 1. Okay, so my translation is x plus 3, y plus 1. So point C then, which is at 4, 0, would become 4 plus 3 is 7, and 0 plus 1 is 1, 7, 1. Okay. Now we have a translation of 3, negative 4, so that would just take this point and we would add 3 and subtract 4. So I add 3 to the negative 5, I get negative 2, and I subtract 4 from 2, and I get negative 2. Choice 3. Yes. Just double checking that. So we have to graph and label this. Alright, so first let's graph the original. Negative 1, 4. 2, 4. And 2, 0. So that was T, A, P. Okay. Now, T, which is at negative 1, 4, A is at 2, 4, and P is at 2, 0. Those are all going to change to become, well, we're going to subtract 5, and subtract 1. So first we're going to subtract 5 from all the x's. Negative 1 minus 5 is negative 6. 2 minus 5 is negative 3. 2 minus 5 is negative 3. Then we have subtract 1 from all the y's. So 4 minus 1 is 3. 4 minus 1 is 3. 0 minus 1 is negative 1. So there are our coordinates. So now I have to graph that. Negative 6, 3. Negative 3, 3. This is t prime, a prime, and negative 3, negative 1. P prime. Okay. There you have it. What is the image of this point after the composition of transformations defined by a reflection in y equals x and then a rotation of 90? We always do this one first. So a reflection in y equals x takes xy and turns it into yx. So a is at 4, 2, then a prime will become 2, 4. Then a rotation of 90 degrees takes xy and makes it negative yx. So when a prime is 2, 4, a double prime will become negative 4, 2. Choice 1. Right? So it's split into two pieces there. So first we're going to rotate 90 degrees about the origin. That takes xy and makes it negative yx. So 3, negative 2 will become 2, 3. And then when we do a dilation of 4, that will take xy and make it 4x, 4y. So we would take the point 2, 3, and it would make it 8, 12. We have a parallelogram. We want to state the coordinates of the vertices that result from the transformation. A translation of 2, negative 3 followed by a reflection in the line y in the y-axis. The use of the set of axes below is optional, so we're not going to use them because we don't need to. We know the rules. So the first rule is a translation okay. And the way it's written is a translation of a comma b of x comma y goes to x plus a, y plus b. So if we take, not a prime, we're not there yet. A is negative 2, 2. B is 3, 5. C is 4, 2. And D is negative 1, negative 1. And first we do this to it. What we get is negative 2. We should write this a little better actually. Let's not use A and B because we're given 2, negative 3. So let's change this to x plus 2, y minus 3. Okay, because that's really what we're doing for this problem. What I gave you was the general formula. So we're going to add 2 to all the x's. I'm just going to go down the line and do that first. You get 0, 5, 6, 1. Then I'm going to subtract 3 from all the y's. Negative 1, 2, negative 1, negative 4. Okay? Then what I want to do is a reflection in the y-axis, which takes x comma y and turns it into negative x comma y. So a prime, b prime, c prime, and d prime, which I know are the values I just found above, will now become a double prime, b double prime, c double prime, d double prime. So I'm going to change the sign of x and leave y alone. 0, negative 5, negative 6, negative 1, negative 1, 2, negative 1, negative 4. Okay, so state the coordinates that result. These are the final coordinates. And we did the translation first. Okay? There you have it. We didn't need the graph. If you want to use the graph, on the regions, of course, you use the graph. Alright? Just to double check your answers. Okay. So, first we have a translation of negative 4, 3, which would take xy and make it do x minus 4 and y plus 3. So we have A, which is at 3, 2, and B at 7, 1. We would get A prime and B prime. First I'll subtract 4 from the x's, negative 1 and 3, and then I'll add 3 to the y's, 5 and 4. Then we're going to do a dilation of 2, which will take xy and make it 2x comma 2y. So my A prime, which is negative 1, 5, will become A double prime at negative 2 comma 10. And my B prime, which is 3, 4, will become my B double prime, which will be 6 comma 8. So that would be choice 1. And again, this was 2 separate transformations. Okay, so we want to graph on this grid x and y. So we have 1, 3, negative 2, 2, and 0, negative 2. So we have A, B, C. Okay? So what we have to do is a translation of 3 comma negative 2 followed by a dilation. So actually we didn't even have to graph that original one, we just have to graph the final one. So let's actually take that out. Let's not do anything more than we need to at this point, because that just leaves room for more mistakes as far as I'm concerned. So okay. So a translation of 3, negative 2. We'll take xy and we'll make it x plus 3, y minus 2. So first, I have a here, b here, and c here. So then I will get a prime, b prime, and c prime. First I'll add 3 to the x's, 4, 1, 3. Then I'll subtract 2 from the y's. 1, 0, negative 4. Okay, that's the first part. Then I have to do a dilation of 2, which takes xy and makes it 2x, 2y. So I take my a prime, b prime, and c prime, which is 4, 1, 1, 0, 3, negative 4, and it becomes a double prime, b double prime, c double prime. First I'll times my x's by 2, so 8, 2, 6. Then I'll times my y's by 2, 2, 0, negative 8. Okay, so here's the coordinates. Now I have to plot them also. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. That's a double prime. B double prime is 2, 0. Okay. And C double prime is 6, negative 8. So when it says graph and label, it means you just have to label the points with the letter. Okay, but don't forget that these are double primes, right? So graph and label and state the coordinates, which I did over here. So I did both. And that's all you have to do. Okay, so now we have to do first a dilation and then a translation. So we're going to do a dilation of 2, which takes xy and turns it into 2x, 2y. And my coordinates are g is 3, 1, h is 5, 3, and s is 1, 4. So I get g prime, h prime, s prime. First I'll multiply the x's by 2, 6, 10, 2. Then I'll multiply the y's by 2, 2, 6, 8. That's the first part. Now I have to do a translation of negative 3 comma 1, which takes xy and makes it x minus 3 comma y plus 1. So my g prime, which is 6, 2, and my h prime, which is 10, 6, and my s prime, which is 2, 8, will become g double prime, h double prime, s double prime. And I subtract 3 from all my x's. I'll do that first. 3, 7, negative 1, and I add 1 to all my y's. 3, 7, 9. So it says graph and state. So here's where I'm stating the coordinates. And I'm going to graph it also. 3, 3. 7, 7. And negative 1, 9. So this is S double prime. This was H double prime. And this one was G double prime. Okay. The coordinates of a trapezoid are that. This is an image after the composition of this. State the coordinates. We don't need to use the axis, okay? So first we'll do a reflection in the line y equals x, which takes xy and makes it yx. So A is negative 4, 5. B is 1, 5. C is 1, 2. And D is negative 6, 2. Those will all change. Okay, so I'm going to switch them. So 5, negative 4. 5, 1. 2, 1. 2, negative 6. That's the first part. Then I do a reflection in the x-axis, which takes xy and makes it x negative y. So I now have A prime, B prime, C prime, and D prime. 5, 5, 2, 2. Negative 4, 1, 1, 6. Okay. They will become x's stay the same. 5, 5, 2, 2. Y changes sign. 4, negative 1, negative 1, negative 6. There it is. Okay, this is something very similar. First we have a reflection in the line y equals x, which takes xy and makes it yx. So we have three coordinates. Okay, so we have 5, negative 6, negative 2, negative 7, 4, 1. Then we do a translation of negative 2, 3 on xy, which makes it x minus 2, y plus 3. So we're going to take our prime points and we're going to translate them according to this rule to get our double prime points. Subtract 2 from each, 3, negative 4, and 2, and then add 3 to each. Negative 3, negative 4, 4. So that's it. Box them off. Let's go to the next problem. 385. So, this one wants to know what happened here as far as the orientation and if it's a reflection or a translation. Well, it's definitely a reflection. And the orientation in the top one goes like this, And in the bottom one, it goes like this. So it's opposite orientation and a reflection. Okay, this is going to be reflected in the x-axis. What will not be preserved? The length of AB will, the measure of angle A will, the parallelism of AB and CD will be preserved. The slope of AB will be different. A transformation of a polygon that always preserves both length and orientation is a translation. Quadrilateral MNOP is a trapezoid with MN parallel to OP. If the image, after reflection over the x-axis, which two sides are parallel? Okay, so let's say we have an x and a y-axis, right? Okay, so let's say we have a trapezoid that looks like this. And MN, OP, these are parallel. If we then flip it, we would have N prime, M prime, P prime, O prime. So which two sides of the quadrilateral are parallel? Well, it's still M prime, N prime, and O prime, P prime. Choice 1. We have a pentagon with PQ parallel to TS. After a translation, which line segment is parallel to PQ? Well, TS, because translating it does not affect that. Okay? So it's the same one. When a quadrilateral is reflected over the line y equals x, which geometric relationship is not preserved? Orientation. When you reflect something, the orientation always changes. Okay? If this thing is reflected over the x-axis, the only one that would remain unchanged is one that lies on the x-axis. So any y coordinate of 0, okay, this one and this one would be on the x-axis. So A and D wouldn't change. So 2 points. Alright, let's see this one. Alright, so this is ABC. All I have to do is graph something anywhere I want that results in A, B being, so all I'm doing is essentially translating this thing. Okay, so I'm just going to actually move everything down like 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one would be one below that. And this one is 1, 2, 3, 4, 1, 2, 3, 4, and 1 over. So there you have it, C prime, B prime, and A prime. That's how I chose to move it. And you can see that AB and A prime, B prime are parallel. Okay? Alright, let's see. Okay. So this one says we have to graph it, so let's draw our axes. One, 1, 5, 1, 5, 4. D, E, G. Okay, it's rotated 90 degrees. So remember, a rotation of 90 degrees takes xy and turns it into negative yx. So if I have 1, 1, 5, 1, and 5, 4, negative 1, 1, negative 1, 5, negative 4, 5. Okay, so it wants me to graph this also. So negative 1, 1, negative 1, 5, and negative 4, 5. So D prime, E prime, G prime. Okay. State the coordinates of the vertices. Okay, so here they are. They're stated. Justify that the transformation preserves distance. So, DE equals 1, 2, 3, 4. And D prime, E prime equals 1, 2, 3, 4. So we'll check that off. EG equals 3, and E prime, G prime equals 3. So we'll check that one off. DG equals, well, DG squared equals 3 squared plus 4 squared, because that's a right triangle. So then DG squared equals 9 plus 16. DG squared equals 25. So then DG equals 5. And we can do the same thing for D prime, G prime squared. That equals 3 squared plus 4 squared. So D prime, G prime squared equals 9 plus 16. D prime, G prime squared equals 25. D prime, G prime then equals 5. So that justified it. Okay? So I had to show that all the lengths of the pre-image and the image sides are the same. Okay, so first we have to graph the original. So A, ABC. Okay. When we do a translation of 5, negative 2, it takes xy and it makes it x plus 5, y minus 2. So if I have the coordinates that they gave me that I just plotted, whoop, and I perform this translation on it, I would get the following. Add 5 to the x's, 7, 7, 9, subtract 2 from the y's, negative 4, negative 1, negative 4. So we have to graph this also. Seven, negative 1. Oh, okay. And 9, negative 4. I'm going to say something looked funny there, but it actually is perfect. So then we have A prime, C prime, and B prime. Now, what else? Determine the relationship between the area and justify your response. So, the area of ABC equals 1/2 base times height, which equals 1/2 times the base is 2 times the height is 3, which equals 3. Let's put units squared. The area of A prime, B prime, C prime is 1/2 base times height, which is 1/2 times 2 times 3, which is 3 units squared. The areas are both 3 units squared because a translation does not change the size or shape of the triangle. Okay. 395. Which transformation of the line x equals 3 results in an image that is perpendicular to the given line? Well, if we have an x and a y-axis and an x-axis, and we have x equals 3, that would be right here. Which line would be perpendicular to this if we reflect it over the line? Think about that, this line. Y equals x. This now would be pointing here, right? And this piece would be flipped this way. And these would all be perpendicular. And this is y equals x. So, it's 3. We have a dilation of a scale factor of 2. The angles don't change in a dilation, right? The perimeters, the areas, and the side lengths change, but not the angles. We have a triangle graphed. Which transformation produces an image that is similar to, but not congruent to, the triangle? A dilation produces a similar figure, right? But the size changes, so it's not congruent. When the dilation is performed on a hexagon, which property of the hexagon will not be preserved in its image? The lengths of the sides will change, right? Everything else listed there will stay the same. Let's see. the measure of angle K is 36, and then it's dilated by 2, the measure of angle K will not change. So the measure of angle K prime will equal 36 degrees because under a dilation, angles do not change. It produces similar figures. Oh, and then so, let's see, K prime M prime would equal 2 times Km which would equal 2 times 5, which would equal 10. And that's because under D2, all side lengths are multiplied by 2. Let's see. If we slid the, no, this would have to be a rotation, okay, of 180 degrees. This one was a glide reflection. First it slid or glided and then it reflected. So it's a glide reflection. Dilation is the only one that could change size. Okay, so isometry means does not change size. So which one is not always in isometry would be dilation, because it can change size. Which transformation can map the letter S onto itself? Ready? Watch this. If I turn this page around, upside down, you still have S. So I just rotated it 180 degrees and you still have the same letter S. So that would be a rotation. A 180 degree rotation. That would have to be a reflection across the line y equals x. Right? It would flip that one right onto the other one. Okay, let's see. This one's a rotation. Right? Watch this. If I rotate 180 degrees, you have the same thing. Okay? Whoop. So that's the answer, rotation. For this one, again, it is rotation. Wait. Yes, it's a rotation. No, wait a second. Let me think about this. Not so sure about that. No, it's not a rotation. It would be a glide reflection. It would slide and then reflect. Choice 2. We would say yes. When you reflect an object, it does not change size. Okay, so this thing was, let's see, it went from bigger to smaller, so it's got to be either 3 or 4, and it rotated 90 degrees would only take it like that. All right, so it had to rotate 180 degrees. So it has to be choice 3. It has to dilate by a half, rotate by 180, and then dilate by a half. Choice 3. Dilations always produce figures that are similar but not congruent. Okay, so first this thing translated and then it reflected. So translated followed by a reflection. That's choice 4. Okay. It moves 2 to the right in the positive x direction. 2 to the right. The area is not going to change if you translate and then reflect, right? It doesn't change the size of the shape. So if the area is 28, well, what's the area? 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6, 7. 4 by 7. 4 by 7 equals 28. So it's still going to be exactly 28. It's not going to change. Okay, we got a bunch of information here. If we have a median BF, we know that AF and FC will be equal. So there it is. Okay, because a median bisects the side. So AF, and let me try to draw that a little better. AF and CF would be congruent or equal. Okay. What is the negation of the statement, the sun is shining? The sun is not shining. What is the negation of the statement, squares are parallelograms? It is not the case that squares are parallelograms. Let me just check something. What is the negation of the statement, I am not going to eat ice cream? I am going to eat ice cream. Choice 2. Which statement is the negation of 2 is a prime number, and what is the truth value of the negation? It would be 2 is not a prime number, and that would be false because 2 is a prime number. That was choice 1. 418. A student wrote the sentence, 4 is an odd integer. Which is the negation and what is the truth value of the negation? So 4 is not an odd integer, and that would be true. So 418 is 2. Given the statement, the medians of a triangle are concurrent. Write the negation of the statement and give the truth value. The medians of a triangle are not concurrent. Truth value is the medians of a triangle are not concurrent. The truth value is false because in a triangle the medians in fact are concurrent. They all intersect at one point. That's what concurrent means. Write the negation of the statement 2 is a prime number. 2 is not a prime number. And the truth value is false, because 2 is a prime number. Which compound statement is true? A triangle has 3 sides and a quadrilateral has 5 sides. So true and false equals false. A triangle has 3 sides. True if and only if a quadrilateral has 5 sides is false. If a triangle has 3 sides, so if true, then a quadrilateral has 5 sides, then false, that's false. A triangle has three sides, true, or, this is an or, a quadrilateral has five sides. So a TRF is true. Okay, anytime you have an or, the T part, I mean, if either one of them is true in an or statement, the whole thing is true. Okay? The statement x is a multiple of 3. X is a multiple of 3. And x is an even integer is true when x is equal to 6. Two is an even integer or 3 is an even integer. Determine the truth value of this disjunction. Justify your answer. So 2 is an even integer, true, or 3 is an even integer, false, equals true. In a disjunction, which I'll put in parentheses an or, if one of the parts, if one of the two parts is true, the whole thing is true. Okay? What is the inverse of the statement? If two triangles are not similar, their corresponding angles are not congruent. So we just switch the two statements. No. We do the negation of both of the statements. So let me just see something. That was 420. Okay. 424. We just negate both. So if two triangles are not similar, so we're looking for if two triangles are similar. So it's either 1 or 3. Their corresponding angles are not congruent. So we're looking for their corresponding angles are congruent. So it's not 1, then it's 3. You negate both. What is the converse of the statement? If Bob does his homework, then George gets candy. The converse means switch their places. So it would be if George gets candy, then Bob does his homework. Choice 1. Contrapositive means switch and negate. So it would be if I do not bump my head, then I am not tall. So where is that? If I do not bump my head, no. If I do not bump, then I am not tall. Choice 4. We switch and negate. Which statement is logically equivalent? The contrapositive is always logically equivalent. So if it is warm, then I go swimming. If I do not go swimming, then it is not warm. Choice 3. Hold on a second. Okay. Write a statement that is logically equivalent. That means write the contrapositive to the statement. If two sides of a triangle are congruent, then the angles opposite those sides are congruent. So if two sides of a triangle are congruent, it would be, if we wanted to rewrite this correctly, we would say if two angles of a triangle are not congruent, comma, then the sides opposite those angles are not congruent. Okay. In the diagram of triangle ABC and DEF, AB is congruent to DE, A is congruent to D, and B is congruent to E. Which method can be used to prove the two triangles are congruent? Angle, side, angle. So here it says the diagonal AC is drawn in parallelogram ABCD. AC is drawn. Which method cannot be used to prove that the two triangles are congruent? Well, in a parallelogram we know these are congruent, we know these are congruent, and we know the diagonal is congruent to itself. So we can do side, side, side. So it's not that one. We also know that these angles are congruent, so side angle side works. Oh, angle side angle would also work because we know that this angle and this angle and this angle and this angle are the same also. And SSA isn't even a way to, doesn't even work. Okay? It's not even a valid method for proving triangles congruent. Let's see. GAE, we have two angles and two sides congruent. To prove that blah 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 are congruent by SAS, what other information is needed? We would need to know that AG is congruent to OL. SAS, SAS. Choice 2. AB is parallel to CD. Angle ABC is congruent to CDA. And diagonal AC is drawn. Which method can be used to prove? Well, we know that these two sides, well, we know that that side is congruent to itself, right? So really we only need to put one here because that's the first one we're identifying. Let's see. Well, SSA never works, okay? That's not a valid way to prove something, okay? So it's going to be SSA. This is number 432. Whoop, hold on a second. Oh, which method can be used? Alright, let me make sure I didn't do that other one wrong. .30. Okay. Yeah, that one's fine. So this one now, which method can be used? Well, if these lines are parallel, we know that alternate interior angles are congruent. So we can use angle, angle, side, angle, angle, side. Choice 1. AC bisects angle BAD, so this is congruent to this, and angle B is congruent to angle D, and we know that they share a side, so angle, angle, side. Choice 4. Okay. In parallelogram ABCD shown below, the diagonals intersect at E. Which statement must be true? It's a parallelogram. So AC congruent to DB? No. ABD congruent to CBD? CBD? No. AED congruent to CEB? Yeah, we know that one must be true because they're vertical angles. Let me just check that one. AED, CEB. Yep, vertical angles. So 434 is choice 3. 435. In the diagram below, we have two triangles. AB, okay. AE is congruent to CE. And BCE is congruent to DAE. And we also know that vertical angles are congruent. So it can be proved congruent by angle, side angle, angle, side angle. Choice 1. 436. We have this trapezoid. We know that these sides are parallel in a trapezoid. That's a rule. And ABC, triangle ABC, so this triangle is congruent to this triangle, it's telling us. Okay. Which statement is true based on the given information? AC is congruent to BC? No. CD and AD? No. Angle CDE and angle BAD? No. Angle CDB and BAC. That's true. Okay. Diagram below, two triangles. Which two statements identify corresponding congruent parts for these triangles? Let's see. AB and XY, BC and ZY, AC and YZ. So which one has that right? AB and XY. So it could be 1. AB and YZ. Can't be 2. BC and XY. Can't be 3. BC and YZ. It could be 4. So then C is obviously congruent to Z. Y is congruent to B. And X is congruent to A. So A and X is congruent is choice 4. Okay. 438. Let's see. Two triangles are congruent. Which statement is always true? Let's draw them. K, L, J, M, N, O. Is angle KLJ congruent to NMO? Nope, it would be congruent to this one. Is angle KJL congruent to MON? That's true. Choice 2. Which statement must be true about these two triangles that are congruent? C and Y, no, C and Z, Y and B, A and X. Yeah, it's choice 2. A and X. The other one said AZ and YZ, nope, and CB, and nope, so it's choice 2. We have a pair of congruent triangles. Some angles are congruent, they're given. Which statement must be true? Well, we know that this side is congruent to itself, so we know that these two triangles are congruent because of angle, side angle. So ADB is congruent to CBD. No. ABC is congruent to ADC. Nope. AB and CD. Nope. AD and CD. Yes, we know that AD and CD. We have this line, AC is congruent to BD, so this piece is obviously, if we subtract this piece from both, these two are congruent, so AB and CD are congruent. And one of them probably says that. There, AB equals CD. When writing a geometric proof, which angle relationship could be used alone to justify that two angles are congruent? Vertical. In triangle AED with ABC shown in the diagram below, EB and EC are drawn. if AB is congruent to CD, which statement could always be proven? AC congruent to DB? No. AE and ED? No. AB and BC? No. EC and EA? EC, alright, let me read this again. If AB is congruent to CD, which statement? Let me think about this one. Let me see. What am I not seeing here? Okay. Oh, it's choice 1. AC and DB are obviously going to be congruent then, right? Obviously, if these two are congruent and they share the same piece that's also congruent to itself, then obviously I didn't realize that it said AC and DB in the first question there. So, that one is choice 1. Now, I think we're getting into some proofs here. Let me just see. The next problem is number 444. Yeah. Alright, let's take these out. So, here we have question 444. Okay? So, we always have statements and reasons. The first one is always the given information. C is the midpoint of BC and AE. And that is given. Okay. Now we can say if C is the midpoint of BD and AE, then we know that those segments are congruent. So we can say that AC is congruent to CE and BC is congruent to CD. And that's by, we can write definition of midpoint. Now number 3, we know that these two angles are congruent, so angle ACB is congruent to angle ECD, and that's because of vertical angles. Now we know the two triangles are congruent, so ABC, triangle ABC, is congruent to triangle EDC, and that's by angle, side angle side. So then for number 5, we could say that angle CDE is congruent to angle CBA. And that's because of CPCTC. Now for number 6 we can say, I would probably say BD is a transversal intersecting AB and ED. And I would say and AB is parallel to DE. And I would say because what would I say? I would say alternate interior angles are congruent. And that would be the angle. In parentheses I'll put angle CDE was congruent to angle CBA. Okay? So that would be the proof for 444. Now let's look at 445. Again, we have statements and reasons. The first one is always the given. AD bisects BC at E. AB is perpendicular to BC. DC is perpendicular to BC. And that's given. So, one of the first things that we can say, since AB is perpendicular to BC and DC is perpendicular to BC, we can say angle ABE and angle DCE are right angles. And that would be because perpendicular lines form right angles. Okay. Choice 3. Now I can say that angle ABE is congruent to angle DCE because all right angles are congruent. Okay. Now I can also say I can say angle AEB and angle DEC, so angle AEB is congruent to angle DEC, and that's because of vertical angles. And I can say that, see here, AD bisects BC at E. So I know that BE is congruent to CE. And I can say that, just give me one sec. can say that because definition of a bisector. Okay. Then for number 6, I can say that two triangles are congruent. So triangle ABE is congruent to triangle DCE. And that's because of ASA. Right? So now finally I can say AB is congruent to DC, and that's because of, here's AB and here's DC, because of CPCTC. CPCTC. Okay, there you have it, 445. Let's look at 446. It's a parallelogram. A student wrote the proof below to show that a pair of its opposite angles are congruent. So we know a lot of things about a parallelogram. We know this side is congruent to this side, and this side is congruent to this side, and this side is congruent to itself, and these two sides are parallel. Opposite sides are parallel. We know that this angle and this angle are congruent, and then because of the alternate interior angles, these are congruent, and these are congruent. So let's see. He said BC is congruent to AD and AB because the opposite sides of the parallelogram are congruent. Fine. AC is congruent to CA, reflexive postulate of congruency. Triangle ABC and triangle CDA, side, side, side. Angle B is congruent to angle D because corresponding parts of congruent triangles are congruent. Okay? That would be the correct answer for 446. Now, let's see 447. Okay. So, statements. Reasons. First thing, AD is congruent to BC. And angle DAE is congruent to angle BCE. And that's really all that's given. So let me label that DAE and BCE. Okay. And it's a quadrilateral. Alright, and we want to prove that this little triangle in here is congruent to this little triangle in here. And we already know one angle is congruent. We also know that this little angle right here is congruent to this little angle right here. So first I'm going to write angle AEF is congruent to angle CEG. And I'm going to say because of vertical angles. Now, let's see. What else do we have going on here? Oh, I see what's going on here. We're going to have to show this thing's a parallelogram. Okay, and we can do that because alternate interior angles, you see these two alternate interior angles? They're congruent. That means that these lines are parallel. So what we can first say is that AD is parallel to BC. Alright. And that's because if two lines are cut by a transversal, so that alternate interior angles are congruent, comma, the lines are parallel. So for now, number 4, so now I know these lines are also parallel. Now I can say that ABCD is a parallelogram. Okay, and I can say that because if one pair of opposite sides of a quadrilateral are congruent and parallel, then it is a parallelogram. Okay? And why do I care about that? Because I know that the diagonals of a parallelogram bisect each other. So now I can say that AE is congruent to CE. And that's because diagonals of a parallelogram bisect each other. Now I can say triangle AEF is congruent to triangle CEG because of angle side angle. Okay, so that was number 447. Okay, let's look at another one. All right. 448. We're given quadrilateral ABCD. So I always draw my quadrilaterals looking like a parallelogram, because that's typically what we need. AB is congruent to CD, and AD is congruent to BC, and there's a diagonal BD drawn, which is obviously congruent to itself. So this one is very, very easy. Statements. Reasons. Number 1, AB is congruent to CD, AD is congruent to BC. That's really it. And that's given. Then we can say BD is congruent to BD by the reflexive property. Okay. Now we can say triangle ABD is congruent to triangle CDB because of side, side, side. And now we can say that angle BDC is congruent to angle ABD because of CPCTC. Okay? So that one was pretty straightforward. Now, that's it for tonight.